Students, in this first video, I am presenting the virtual lab for doing the experiment verification of Brewster's law. For this one, first we see what is this Brewster's law and we proceed how to do that experiment. For this one, we go with the statement first now. Okay, it states that for a particular angle of incidence called angle of polarization or Brewster's angle, the reflected ray is plane polarized to its maximum intensity and the refracted ray is partially polarized, and also the refracted ray is perpendicular to the reflected ray. Then if we see the diagram, then we can easily understand from the diagram that R plus IB is equal to 90 degrees, where IB is the Brewster's angle and R is the angle of refraction. Then R becomes 90 minus IB, and if you take the refractive index of the material, that is mu, it is written as sin I by sin R, that is sin IB by sin R, where we can substitute R as 90 minus IB, that is we get sin IB by cos IB, that is equal to tan IB, that is the refractive index of the material becomes tan IB for the angle of polarization. Okay, that is what we are going to prove in our experiment to prove the Brewster's law. Okay, for this one we take 2 points into consideration, that is the reflected ray is having its polarization to its maximum intensity and the refracted ray is at 90 degrees to the reflected ray. Using that one, we are getting mu is equal to tan IB, and we use the intensities now. Okay, if we are getting reflected ray with maximum intensity, then the refracted ray is going to have minimum intensity, that is the transmitted ray is going to have minimum intensity, and we change that intensity to current by using a transducer. Then our output current is minimum at this Brewster's angle. Okay, that is what we are going to do in our experiment. Okay, for this one we go to the simulation mode of the experiment. Okay, to do that, first we open Google Chrome browser and in the search box we type blab.co.in. Okay, already it is typed there, we just enter. Then it is what we are seeing now. Okay, then it is the virtual lab provided by Ministry of Education, Government of India. Okay, then if we scroll down that screen, we are going to have participating institutions. Then from them we are going to choose this one, Amrita Viswavidyapeetham. Okay, you click on that one. We are going to have the virtual labs at Amrita Viswavidyapeetham. Then again scroll down, we can find this one, Laser Optics Virtual Lab. You click on that one. Then we are going to have again options here. We have to choose this one, Brewster's angle determination. Click on that one. It shows like that. You can go all through these things, that is theory, procedure, self-evaluation, simulator, all these things. For our experiment, we are going to have this one, simulator. You click on this one and we are going to have this window now. You enlarge this one. Now we have to place these apparatus at their respective slots. First, drag this emitter to the bottommost right. Then we have to place polarizer next to it. Then we have to keep the material holder next to it. Then detector, and finally to measure output we use this current meter. Okay, there we are going to see the angle between polarizer and analyzer. Then again we come on to these variables. You keep this with side view. Then the first medium is air. Choose the material for the second medium. We prefer to take this flint glass. Then if you switch on the light, it is going to show the reading of this output intensity in terms of current. Okay. To change the angle between polarizer and analyzer, we make use of this red spot. If we drag this one to right side, we can increase the angle of incidence. Okay, we can use arrow marks also, right arrow. Then first you bring that one to 51.1, not 51.1, 56.1. Okay, then you can see the reading on the screen. For this angle of incidence 56.1, okay, we have to note that output. Then before doing this one, you take off your noses and you just make two columns. For the first one, angle of incidence, and in the second column we are going to take the output current values in milliamperes. Okay, for the angle of incidence 56.1, you note down the reading 1.0438. Then we increase this angle in steps of 0.2 degrees. That is, we next take this one to 56.3. The reading is now 1.0322. Okay, next for 56.5, the reading is 1.0224. Next for 56.7 degrees, the reading is 1.0144. 1.0144. Okay, for 56.9, it is 1.0081. For 57.1, it is 1.0036. For 57.3, it is 1.0009. For 57.5, it is 1.0000, that is 1. Then for 57.7, again the reading is increasing, 1.0008. For 57.9, it is 1.0035. Then for 58.1, it is 1.0079. Then for 58.3, it is 1.0140. Then for 58.5, it is 1.0220. Then for 58.7, the reading is 1.0317. Okay, you note down these readings. Okay, these readings are sufficient. Now you minimize this one and you open the Excel sheet and you take down those readings in this Excel sheet. Okay, first column is serial number, second one is angle of incidence in degree, that is the next column is output current. Okay, generally we take this one as a milliampere. Now you choose these two columns and you go to insert option, and here we are going to find charts. In this chart we are going to have this scatterer. Then you take the top middle, then it is going to show the graph. So bring this one to this slot and increase this one. Now we change this one. We remove the grid lines and we are going to name the axis, okay, primary x-axis and vertical axis. Okay, this horizontal axis we take the values of incidence angle. Incidence angle, we are going to take those things in degrees, that is we measure in degree. Then come to the vertical axis, it is output current. We take the values in milli. Now we change the heading. It is the Brewster's law. Brewster's law. Now we change this color to black, because if we take the printout, then it is not good. To get good quality of printout, we choose the black color here. Okay, then again data labels. In these data labels, you click on this one and go for more options. Okay, there is no need to have these y values. We are interested in x values, and you place those values above those points. And we go for alignment. For alignment, we choose this vertical like this. Okay, and there is no need to have all these values. We delete these values except the minimum one. Okay, we keep that minimum one. Okay, now I choose the entire table and I go to the home and prefer to have the font in the Times New Roman. Okay, then again I have to choose this vertical axis. For this vertical axis, I have to give the uh, line color, that is black color, and we increase the strength of the line to 1.5. In the same way, we choose horizontal axis and we change the color to black and increase the strength to 1.5. Okay, then we increase this one to, we increase the font size to 14 and we make that one bold. Okay, that is Brewster's angle. This is the Brewster's angle. Okay, then we select all these things and we paste this one. We take another Word document, and here we paste the values like this. Okay, then we have to write this one. From the graph, Brewster's angle IB is 57.5 degrees. Okay, you have to paste after pasting this one. Then the refractive index mu is equal to tan IB 1.57. Okay, which is equal to the critical value. Hence, Brewster's law is true. Okay, then this is how we can prove the Brewster's law. Okay.